In this video, we'll see what are the properties of Bessel function and also few problems on Bessel's function. First property is j minus n of x is equal to minus 1 power n into j n of x, where n is a positive integer. By the definition of Bessel function, we have Jn of x is equal to sigma r equal to 0 to infinity minus 1 power r into x by 2 to the power of n plus 2 r into 1 divided by r factorial into gamma of n plus r plus 1. This is by definition of Bessel function Jn x. We require j minus n of x. So put n is equal to minus n. J minus n of x is equal to sigma r equal to 0 to infinity minus 1 power r into x by 2 to the power of minus n plus 2r. Just I replaced n by minus n into 1 divided by r factorial into gamma of, here I replace n by minus n plus r plus 1. We'll call it as equation 2. In equation 2, gamma of minus n plus r plus 1 is equal to gamma of r minus of n minus 1. Minus n plus 1, in those two minus have taken outside, minus of n minus 1 is of the form gamma of minus k. Gamma of minus k for r is equal to 0, 1, 2, 3 up to n minus 2. And gamma of 0, okay, for n r is equal to n minus 1. Gamma of minus k tends to infinity. So 1 divided by gamma of minus k tends to 0. So this result 1 divided by gamma of minus n plus r plus 1 value equal to 0 for r equal to 0 to n minus 1 it is. So it is the form where r equal to 0 to n minus 1, j minus n of x is equal to, those values are 0. Remaining is r is equal to 1 to infinity minus 1 power r into x by 2 to the power of minus n plus 2r into 1 by r factorial into gamma of minus n plus r plus 1. We'll call it as equation 3. Now, put r minus n is equal to, here r minus n is there, no? Put r minus n is equal to s, or r is equal to s plus n. So that we have r is equal to n, when r is equal to n, s is equal to 0. And r is equal to infinity, s is also equal to infinity. So that j minus 1 of x is equal to summation s is equal to 0 to infinity minus 1 to the power of, okay, that is r minus n have taken it as s into gamma x by 2 to the power of minus n plus 2s plus 2n into 1 by gamma of s plus 1 into s plus 1 factor, s plus n factorial. Summation s is equal to 0 to infinity minus 1 to the power of s plus n into x by 2 to the power of, and simplification, it will be 2n minus n is n plus 2s into 1 by gamma of s plus 1 into s plus n factorial. Using the properties of gamma function, we can write this as gamma of s plus 1 is s factorial and gamma of s plus n plus 1 is equal to s plus n factorial. So instead of s plus n factorial, I have written it as gamma of s plus n plus 1, and s plus 1 I am writing it as s factorial. So j minus n of x is equal to summation s is equal to 0 to infinity minus 1 to the power of s plus 1 s plus n into x by 2 to the power of n plus 2s into 1 by s factorial into gamma of s plus n plus 1. This will take minus 1 power n outside, minus 1 power n into summation r equal, instead of s I can replace it by r equal to 0 to infinity minus 1 to the power of r, okay, x by 2 to the power of n plus 2r into 1 by r factorial into gamma of n plus r plus 1, r is s is equal to 0 to infinity. Both are same meters. Okay, this is nothing but jn of x. Comparing this with equation 1, okay, and that is equal to jn of x. Hence, j minus n of x is equal to minus 1 power n into jn of x. There are two properties among these two properties. One property definitely they are asking in the examination. Second property is Jn of minus x is equal to minus 1 power n into Jn of x. That is nothing but j minus n of x, where n is a positive integer. Once again, by definition, Jn of x equal to sigma r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of n plus 2r into 1 by r factorial. Sorry, r factorial I have written 1 over gamma of n plus r plus 1. Here I required Jn of minus x. So put x is equal to minus x. Sigma r equal to 0 to infinity minus 1 power r divided by r factorial into, I am replacing x by minus x by 2 to the power of n plus 2r into 1 over gamma of n plus r plus 1. Summation r equal to 0 to infinity minus 1 power r divided by r factorial into, I am splitting this as minus 1 to the power of n plus 2r into x by 2 to the power of n plus 2r, or else x to the power of n plus 2r divided by 2 to the power of n plus 2r into 1 over gamma of n plus r plus 1. Minus 1 power n, I am taking that outside. Sigma r equal to 0 to infinity. Okay. Minus 1 to the power of r can be written as minus 1 whole cube whole to the power of r. Minus 1 whole cube is nothing but minus 1 itself it is. Minus 1 power r itself. R factorial x by 2 to the power of n plus 2r into 1 over gamma of n plus r plus 1. Minus 1 power n into sigma r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of n plus 2r into 1 over gamma of n plus r plus 1. This is nothing but Jn of x it is. Okay. Here minus 1 power r is there, minus 1 power 2r is there. Together minus 1 to the power of 3r. I have written minus 1 power 3r as minus 1 whole cube whole power r it is. Okay. Hence Jn of minus x is equal to minus 1 power n into Jn of x. Already we proved that j minus n of x is equal to minus 1 power n into j n of x. Hence this is also equal to j minus n of x. This is the second property. Okay. Among those two properties, one property definitely they are asking in the examination. Please learn both. First problem, prove that. Okay. J of x is equal to square root of 2 by pi x into 2 sin x. Second problem is prove that j minus of x is equal to square root of 2 by pi x into 2 cos x. By definition, Jn of x is equal to sigma r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of n plus 2r into 1 over gamma of n plus r plus 1. Okay, here we require j of x. So put n is equal to 1 by 2. So equation 1 takes the form j of x is equal to sigma r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of, okay, n is 1 by 2 plus 2r into 1 over gamma of n is 1 by 2 plus r plus 1. J of x is equal to, okay, x by 2 to the power of 1 by 2 plus 2r is there. So x by 2 to the power of 1 by 2 is nothing but square root of x by 2. I have taken that outside. Remaining is sigma r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of 2r into 1 over gamma of 1 by 2 plus 1 is 3 by 2, r plus 3 by 2. On expanding we get, okay, square root of x by 2 into, okay, if r equal to 0, minus 1 power 0, 1, 0 factorial is 1, x by 2 power 0 is 1, okay, 1 by gamma of 3 by 2, okay, plus when r is equal to 1, minus 1 power 1 is minus 1, 1 factorial is 1, x by 2 to the power of 2, okay, 1 by gamma of 1 plus 3 by 2, it is gamma of 5 by 2, plus when r is equal to 2, minus 1 whole square is 1 by 2 factorial, x by 2 to the power of 4, 2 to the 4, 1 by gamma of 2 plus 3 by 2, 2 to the 4, 4 plus 3, 7 by 2 plus dot dot, okay. Root of x by 2 into gamma of 3 by 2 can be split as gamma of 1 by 2 plus 1, gamma of n plus 1 is n into gamma of n, 1 by 2 into gamma of is root pi, minus 1 factorial is 1 itself, x by 2 whole square into gamma of 5 by 2 can be written as 3 by 2 into 1 by 2 into 2 root pi. Already you have learned how to write these values in the first semester. Plus 1 by 2 factorial is 1 by 2, x by 2 power 4, gamma of 7 by 2 is 5 by 2 into 3 by 2 into 1 by 2 into 2 root pi, okay. 1 1 by 1 by 2 root pi is nothing but 2 by root pi minus x square by 4 into 2. Okay, 3 root pi and divided by 4, that 4 goes to numerator. 4 by 3 root pi plus x to the power of 4 divided by 2 to the power of 4 is 16. 16 to the 32, and here 2 to the 4, 4 to the 8 goes to numerator, divided by 15 root pi. Actually this root pi should be in the denominator. Okay, and in all the terms, here 4 4 gets cancelled, 8 4s are here also get cancelled. Okay, and take 1 by root pi outside, remaining is 2 minus, okay, x square by 3 plus x to the power of 4 divided by, okay, 60, or x by, okay, 2 pi into 2 minus x square by 3 plus x to the power of 4 divided by 60 plus dot 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 x by square root of x by 2 pi into 2 by x I am taking outside. Here 2 is there in the numerator but x is not there in the denominator. So divide and multiply by x. So x remains in the numerator minus. Here one more x in the numerator and 2 in the denominator. 2 3 is a 6. X cube by 6 plus x to the power of 5 by 62 is a 120 plus dot dot. Okay, here 2 by root 2 is root 2, root x by x is root x. So 2 by square root of 2 by pi x into x minus x cube by 3 factorial plus x to the power of 5 divided by 5 factorial plus dot dot. J of x is equal to square root of 2 by pi x into this infinite series is nothing but the sine series, sine x. Okay, now to prove the second result, by putting n is equal to minus 1 by 2 in equation 1, we have j minus half of x is equal to sigma r equal to 0 to infinity minus 1 to the power of r divided by r factorial into x by 2 to the power of minus 1 by 2 plus 2r into 1 over gamma of minus half plus r plus 1. Okay, x by 2 power minus 1 by 2 are taken outside. Remaining is r equal to 0 to infinity minus 1 power r divided by r factorial into x by 2 to the power of 2r into 1 over gamma of r minus of plus 1 is half. Okay, 1, this is x by 2 to the power of minus 1 by 2 is nothing but 2 by x to the power of 1 by 2, that is nothing but square root of 2 by x. Okay, if I expand this, r equal to 0, minus 1 power 0 1, 0 factorial is 1, x by 2 power 0 is 1, 1 over gamma of 1 by 2. Okay, for r is equal to 1, minus 1 power 1 is minus 1 by 1 into x by 2 power 2 into 1 over gamma of 1 plus 1 by 2 is 3 by 2. For r is equal to 2, minus 1 whole square is plus 1 by 2 factorial into x by 2 to the power of 2 to the 4 into 1 over gamma of 2 plus 1 by 2 is 5 by 2. When r is equal to 3, we are getting this term. Okay, and gamma of is root pi minus x square by 4, gamma of 3 by 2 is 1 by 2 root pi, 1 by 2 factorial is 2, x to the power of 4 divided by 16 into gamma of 5 by 2 is 3 by 2 into 1 by 2 into root pi minus 1 by 3 factorial is 6 into x power 6 divided by, okay, 64 into 2, gamma of 7 by 2 is 5 by 2 into 3 by 2 into 1 by 2 into 2 root pi plus dot dot dot. In all the terms 1 by root pi common, just take that outside, remaining is 1 minus x square divided by, okay, here 4 divided by 2 is there, 2 to cancel 2 plus x to the power of 4 divided by 24 minus x power of 6 divided by 720 plus dot dot. On simplification, okay, this is square root of 2 divided by pi x into 2, this is nothing but cosine series, that is j minus half of x is equal to square root of 2 by pi x into cos x. Only 2 problems. Okay, and orthogonal property of Bessel function. This is also very important. Definitely they are asking this also in the examination. All the derivations are important. No problems in this topic special functions, only the derivations. You need to learn all the derivations. Orthogonal property of Bessel function says that if alpha and beta are two distinct roots of Jn of x is equal to 0, then integration 0 to 1 x into Jn of alpha x into Jn of beta x dx is equal to 0 if alpha not equal to beta, half into Jn dash of alpha whole square for alpha equals to beta. But in the examination they are asking only the first part. Prove that integration 0 to 1 x into jn of alpha x into jn of beta x dx is equal to 0 if alpha not equal to beta. We know that Jnx is a solution of the Bessel differential equation x square d square by dx square plus x dy by dx plus x square minus n square of y is equal to 0. Hence, Jn of lambda x is a solution of the equation x square d square y by dx square plus x dy by dx plus lambda square x square minus n square of y is equal to 0. If u is equal to jn of alpha x and v is equal to jn of beta x, the associated differential equations are x square, okay, d square u by dx square, instead of that u double dash plus x into u dash plus alpha square x square minus n square of u is equal to 0, and v is the solution of some differential equation. The corresponding differential equation is x square v double dash plus x v dash plus beta square x square minus n square of v equals to 0. We'll call these equations as 1 and 2. Multiplying equation 1 by v by x and equation 2 by u by x, we obtained. Okay. I'm multiplying this by v by x. 1x gets cancelled. X into v into u double dash. X gets cancelled. V into u dash plus alpha square. Okay. 1x gets cancelled. Alpha square uvx minus n square uv by x equal to 0. And second equation by u by x. So 1x gets cancelled. X u v double dash plus x, okay, xx gets cancelled, u v dash plus 1x gets cancelled, beta square x u v minus n square u v by x is equal to 0. And subtracting, okay, we get, okay, x into v u double dash minus u v double dash plus vu dash minus v dash u plus, in these two uvx is common, alpha square minus beta square of uvx, okay, and these two terms gets cancelled, equal to 0. The first two terms together can be written as d by dx of x into v u dash minus u v dash. On differentiation of this, definitely we are getting these two terms equals to, if I shift this term to right hand side, beta square minus alpha square of uvx. Integrating both sides with respect to x between the limit 0 to 1, we have, okay, integral differential gets cancelled between the limits x equal to 0 to 1 equal to beta square minus alpha square into integration 0 to 1 uvx dx. Okay, when x is equal to 1, this becomes vu dash minus uv dash at x is equal to 1 minus, when x equal to 0, this term is 0 equal to beta square minus alpha square integration 0 to 1 uvx dx. We'll call it as equation 3. Since u is equal to jn of alpha x and v is equal to jn beta x, we have u dash is equal to jn dash of alpha x into alpha. V dash is equal to jn dash beta x into beta. And as a consequence of this, equation 3 takes the form, okay, jn, okay, I substituted jn beta x, u dash I substituted alpha jn dash of alpha x minus, okay, u v dash, okay, u is jn alpha x, v dash is beta jn dash beta x at x is equal to 1, that is equal to beta square minus alpha square into integration 0 to 1 x into u is jn alpha x, v is jn beta x dx. Okay, hence integration 0 to 1 x into jn alpha x into jn beta x dx is equal to 1 over beta square minus alpha square into this term it is, okay, alpha into, when x is equal to 1, it is jn beta into jn dash of alpha minus jn of alpha into beta into jn dash of beta it is. We'll call it as equation 4. Since alpha and beta are two distinct roots of jn of x is equal to 0, we have jn of alpha is equal to 0 and jn of beta is equal to 0. So that these two terms are 0. Hence, with the result, the RHS, if alpha is equal to beta, what happens is 0 provided beta square minus alpha square is not equal to 0. Suppose if beta alpha is equal to beta, what happens is this also 0, this also 0, 0 by 0 form. Hence, this equation, this left hand side is equal to 0 only when alpha is not equal to beta. Okay. Hence, we proved that if alpha not equal to beta, integration 0 to 1, x into jn of alpha x into jn beta x dx is equal to 0. Up to this only in the examination they are asking. Okay. Now, I'll show that. Okay. That is, when alpha is equal to beta, what happens? The RHS of equation 4 is an indeterminate form when alpha is equal to beta. To evaluate this indeterminate form, we need to apply the L'Hospital rule. Okay, that is limit as beta tends to alpha, integration 0 to 1, x into jn alpha x, jn beta x dx is equal to limit as beta tends to alpha 1 over beta square minus alpha square into alpha into jn of beta into jn dash of alpha minus beta into jn of alpha into jn dash of beta. Since alpha is fixed, we must have jn alpha is equal to 0 as alpha is a root of jn of x is equal to 0. Therefore, limit as beta tends to alpha, integration 0 to 1, x into jn of alpha x into jn beta x dx is equal to limit as beta tends to alpha 1 divided by beta square minus alpha square into jn alpha is equal to 0 means this term is 0. Alpha into jn of beta into jn dash of alpha. That's equal to limit as beta tends to alpha. Okay. This is if I differentiate this. Okay. That is applying the L'Hospital rule. Okay, f dash x by g dash x. Okay, this differentiation is alpha into jn dash of beta into jn dash of alpha divided by 2 beta by applying the L'Hospital rule. Okay, now apply the limit as beta tends to alpha. This becomes 1 by 2 alpha into jn dash of alpha into jn dash of alpha, all half into, okay, alpha gets cancelled, jn dash of alpha whole square. Therefore, integration 0 to 1 x into, okay, beta tends to alpha, wherever beta is there I substitute it as alpha, jn square alpha x dx is equal to half into jn dash of alpha whole square. Okay. Further, we have the recurrence relation jn dash of x is equal to n by x into jn of x minus jn plus 1 of x. Therefore, jn dash of alpha is equal to n by alpha into jn alpha minus jn of n plus 1 of alpha. Since jn alpha is equal to 0, we obtain jn dash of alpha is equal to 0. That's equal to minus jn plus 1 of alpha. And equation 6 now takes the form integration 0 to 1 x into jn square alpha x into dx is equal to half into jn plus 1 of alpha whole square. Okay, this result is known as the, okay, Lommel integral formula. Okay, and in the examination it is not there in your syllabus, only the first part. Prove that integration 0 to 1 x into jn alpha x into jn beta x dx is equal to 0 if alpha not equal to beta. Only this much you have in the examination. Okay, enough. In the next video, I'll explain you what is the series solution of the Legendre differential equation. Till that, take care. Bye.